Hello students, in the last lecture we have discussed about an equivalence relation and partition, and we have seen how an equivalence relation forms a partition of a set. Now I have asked at that time I have asked you to test but to create an equivalence relation from a given partition. If equivalence relation is known, then we can form the partition. Conversely, if the partition is given, how we will define an equivalence relation on that set? That means how a partition of a set induces an equivalence relation on that set. Okay, here I have to tell you that I will speak in English. I will teach in English, but wherever I feel it is required to speak in Oriya for the Cse students, I will speak. Okay, because we have to answer in the exam in the English language, not in Oriya. It may be Cbse or it may be Chse. So with your request, I will speak in Oriya. Okay? Yes. Now here you see, I have written a set A which has 7 elements, 1, 2, 3, 4, 5, 6, 7, right? It has 7 elements, and I have written a partition of that set A. I have written a partition. What is that partition? 1, 2, 3, 4, 5, 6, 7. What is a partition? A partition is a collection of subsets of the set whose union is equal to A, and the subsets are disjoint to each other and non-empty. Here you see, in the partition there are 1, 2, 3, 4 sets, 4 subsets of A. 4 subsets of A, and each of them is non-empty. First criteria. Each of them is non-empty. Then they are pairwise disjoint. Pairwise disjoint means any two of them have no common element. जे कौन सी दीटा नेले भी हमें तांका भीतर common element किछि पाइबा नहीं. So they are pairwise disjoint, right? Is there any common element? No. Then their union, this set, union this set, union this set, union this set is equal to A. So this is a partition of our set A. This is a partition. Okay, it is a partition of A. Now mark here how we will form an equivalence relation from this with the help of this partition. Yes, F. The relation F on A is defined like this. The set of order pairs Mn. The set of order pairs Mn such that M and N belong to the same set in the partition. Partition में देखो, there are sets. This is a set. This is a set. This is a set. So whenever M and N, 2 elements, they are in the same set of the partition, then only M will be related to N. Here you see 1 and 2 are in the same set. So 1 will be related to 2 and 2 is also related to 1. 1 is also related to 1 because 1 is in the same set as that of 1. So 1 is related to 1, and similarly 2 is also related to 2. Then except these two, 1 is not related to any other element. 1 is related to 1, 1 is related to 2 because they are in the same set. But except these two elements 1 and 2, 1 cannot be related to any other element of the set A. Why? Because except 1 and 2, no other element of A is in the same set as that of 1. 1 जो सेट रे अछि 1 एवं 2 व्यतीत अन्य कौनसी एलिमेंट से सेट रे नाहंती. So, according to our definition, we cannot relate 1 with 3, 1 with 4, 1 with 5, 1 with 6, 1 with 7. We cannot relate. Why? Our definition says, if M is related, if M and N are in the same set, then M will be related to N. So here, 1 cannot be related to any other element of A except 1 and 2. Clear? Now, come to similarly for 2. 1 and 2 are in the same set means 2 is also related to 2, 2 is also related to 1. Now come to 3. 3 cannot be related to 1. Why? Because 1 is not in the set where 3 is present. जो set रे 3 अछि से set रे 1 नाही. In the partition P will लिखा अछि. We have written it is in the partition P. P रे जो set सब अछंती 3 जो set रे अछि 1 से set रे नाही. So 3 cannot be related to 1. And in the similar argument 3 cannot be related to 2 also. But 3 is related to 3. Why? 3 is in the same set as that of 3. 3 जो set रे अछि 3 भी सही set रे अछि. So 3 will be related to 3. 3 will be related to 4. Why? Because they are in the same set. 3 and 4. So 3 will be related to 4 and 3 also related to 5. Okay. Now come to 4. 4 will be related to 3 because they are in the same set. 4 will be related to 4. 4 will be related to 5. Similarly, 5 will be related to 3. 5 will be related to 4. 5 will also related to 5. But what about 6? 5 cannot be related to 6 because except 3, 4, 5, they are not in the same set. 6 and 5. Same set now. So 5 cannot be related to 6. And in the similar argument, 5 cannot be related to 7. Okay. Now come to 6. You see. 6 in a subset where only the element 6 is present. So 6 is only related to 6. It is not related to any other element. Why? Because except 6, no other element of A is in the same set as that of 6. 6 जो subset रे अछि 6 व्यतीत आउ केही से subset रे नाहंती. तेनु 6 आउ का सहित related हे परिबो नाही. And similarly 7 you see, it is a singleton set 7. So 7 will be related to only 7. Now we have formed the relation. It is a set of order pairs. It is a subset of A Cartesian product A Cartesian product A. So it is a relation from A to A. Okay. It is a relation from A to A. But whether it is reflexive, symmetric or transitive, let us test. You see, when it will be reflexive, if each element of A is related to itself, each element of A is related to itself. Yes, let us see whether 1 is related to 1 or not. Yes, the element is here. So 1 is related to 1. 2 is related to 2 or not. Yes, 2 is related to 2. 3 is related to 3. 4 is related to 4. 5 is related to 5, perhaps here. 6 is related to 6. 7 is related to 7. So, yes, each element of A is related to itself through the relation F. So, F is our relation, F is reflexive. Let us test the symmetricity. We just alter the element 1 2, yes, 2 1 is there. 2 1, 1 2 is there. X y, if x is related to y, then y should be related to x according to the definition of symmetric relation. Okay. Now here you see 1 1 2 2 3 3 3 4 4 3 must be there. Yes, there is. 3 5 5 3 must be there. Yes, 5 3 is there. 4 4 4 3 3 4 here. 4 5 5 4 5 4 is here. 5 3 3 5 we have seen. 5 4 4 5 we have seen. Then 5 5 6 we cannot. Yes, it is symmetric. That means we are unable to find an example where x is related to y but y is not related to x. X is related to y but y is not related to x. So we cannot find such an example. So we have to accept, yes, it is symmetric. Now come to transitivity. When an element will be, a relation will be transitive, if x is related to y and y is related to z, implies x is related to z. Yes, let us see. Or in other way, in negative sense, a relation will not be transitive. If we can find an example where x, at least one example, where x is related to y, y is related to z, but x is not related to z. Let us search for such an example. Can you find? If we cannot find, then we have to accept that it is transitive. Yes. 1 2 2 1. 1 1 should be there. Yes, it is there. 2 1 1 2. 2 2 is there. In this way, you can test that if x is related to y, y is related to z, then x must be related to z. Is there? X, z must be there. Right? So it is also transitive. Now this is an F is an equivalence relation only. F is an equivalence relation on. This is how we can induce an equivalence relation from a partition. Okay? Let us see another example of equivalence relation. Very important example, very important relation, that is congruence modulo relation. Congruence modulo relation. Okay? We'll read congruence modulo relation. Yes, congruence modulo relation. On the set of integers. Set of integers. What is congruence modulo relation? You see, if A and B are any two integers and M is a fixed integer, fixed positive integer, then such that positive integer. If It is let a be any two integers and m is a fixed positive integer. Let us take a fixed positive integer, say 5, 7, 6, 7, 8, 9, like this. If a minus b is divisible by m, then we say that a is congruent to b modulo m, right? If a minus b is divisible by m, then we say that a is congruent to b modulo m. Symbolically we write it as a is congruent to b mod m, if and only if a minus b or m divides a minus b. जदि a minus b टा m द्वारा विभाज्य, a minus b is divisible by m, then we say that a is congruent to b mod m. A is congruent to b mod m. When a minus b is divisible by m. Suppose you see, suppose our m is 5. We will take m is equal to 5. Suppose. Then you see 6 minus 1. 6 minus 1. 5 divides this 6 minus 1, because 6 minus 1 is 5. 5 is divisible by 5. 5 also divides 11 minus 1. 5 divides 7 minus 2. 5 divides 8 minus 3. 5 divides 17 minus 2. Understand? 17 minus 2 is 15. 15 is divisible by 5. Okay. So 5 divides 17 minus 2. 6 divides 1. 6 minus 1. 5 divides 11 minus 1. So from this we can write 6 is congruent to 1 mod 5. Then 11 is congruent to 1 mod 5. 7 is congruent to 2 mod 5. 8 is congruent to 3 mod 5. And 17 is congruent to 3 parallel lines, segments, mod 5. Understand? When m divides a minus b, we say that a is congruent to b mod 5, m. Similarly here you see. Okay, this is the relation. Let us see whether this congruence modulo relation is an equivalence relation or not. Congruence modulo relation is an equivalence relation or not. Let us test. Right. Let us take an example. Let Z be the set of integers. Integers, you know, 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 plus 4 minus 4, like this. All whole numbers. Integers. Z is the set of integers. Let us take F. Let F be a relation on Z defined by F is equal to Mn such that M is congruent to N mod phi, right? N mod phi. That is, M will be related to N when M minus N is divisible by 5. M and N are integers. M minus N is divisible by 5. M and N are integers. M and N belongs to Z. Here I should write it. Otherwise confusion. M, N belongs to Z and M is congruent to N mod phi, right? Okay. Let's test whether it is reflexive, symmetric or transitive. When it will be reflexive, if each integer is related to itself, clearly M minus N is equal to 0 for all Z belong. This is for all. ओडिया कोले समस्तंक पाई it is 0. 3 minus 3 0. 7 minus 7 0. 100 minus 100 0. So M minus M is equal to 0 for all N belongs to Z. But 0 is divisible by 5. So M minus M is divisible by 5 for all M belongs to Z, and this implies M is related to M for all M belongs to Z. Okay? If M is any integer, then M minus M is equal to what? 0. You are subtracting the same integer M from M. So M minus M must be 0. But you know that 0 is divisible by any natural number, any positive integer. So 0 is also divisible by 5. When a number will be divisible, when we can write it in the form, suppose divisible by 5 means it is in the form this, right? 5k. From division algorithm, it is better understood. Yes, 5k. So 0 is divisible by 5. So M is related to M for all M belongs to Z. जेकोसी इंटीजर हेले भी सेता निज सहित रिलेशन रखिबो, कारण सेम इंटीजर टू सेम इंटीजर माइनस कले 0 होबो, 0 टा 5 द्वारा विभाज्य, राइट? दिस implies F is reflexive. It is reflexive on Z, right? Number 1. Yes. For next we will test the symmetricity. For M N belongs to Z, let M is related to N. M and N are any two integers such that M is related to N. We have to prove that N is related to M. Okay? So this implies M minus N is divisible by Yes, divisible by 5. This implies m minus n is equal to 5k for some integer k. This implies n minus n, which is equal to minus of n minus n, which is equal to minus 5k, that is equal to 5 into minus k. If k is an integer, then minus 5 minus k is also an integer. You see, m minus n is 5k because it is divisible by 5. From division algorithm we can conclude it is 5 into some integer, divisible by 5 means. Now n minus n is nothing but minus of m minus n. It is minus of m minus n, and in place of m minus n we can write 5k. So it is minus 5k. Minus 5k means 5 into minus k. And you see, if k is an integer, then minus k is also integer. K belongs to z implies minus k in z. So this implies n minus m. So n minus m is divisible by 5. And this implies n will be related to m. Thus, what we get? Mn belongs to f implies nm belongs to f, right? m ro n सहित relation रहले बाध्य होइके n रो m सहित. So f is symmetric. So f is symmetric on Z. This is suppose double star. Now let us test for transitivity. For MNP belongs to Z, let M is related to N and N is related to P. M is related to N and N is related to P. And this implies, because we have to take this for transitivity. What is transitive relation? If x is related to y and y is related to z, then x must be related to z. So first we have to take x, y and y, z and test whether x, z is there or not. Yes, m, n, n, p. This implies m minus n and n minus p are divisible by 5. This implies m minus n is equal to 5k1 suppose, and n minus p is equal to 5k2. It is 5k1, 5k2. For some integers k1 and k2. This implies m minus n plus n minus p is equal to 5k1 plus 5k2. This implies m minus p is equal to 5 into k1 plus k2. Right? And n will cancel each other, minus n plus n. So it is m minus p. M minus p is 5 into k1 plus k2. We know that from closure property of addition in the set of integers, we know that sum of two integers is again an integer. So k1 plus k2 must be, k1 is an integer, k2 is an integer, then k1 plus k2 must be an integer. So 5 into m minus p is 5 into some integer. Okay, so m minus p is divisible by 5. That means m is related to p. Thus, what we have got? M is related to n and n is related to p implies, yes, m is related to n and n is related to p implies m is related to p. We have proved it. So f is transitive on on Z. It is transitive on Z. Thus, this relation, the congruence modulo relation, congruence modulo 5, is reflexive, symmetric and transitive on Z. It is reflexive, symmetric and transitive on Z. So, it is an equivalence relation. It is an equivalence relation on the set of integers. Okay. Now, in next we will see what are the partitions of this equivalence relation. Okay. Today we will close here. Next time we will see how it makes a partition of Z. Then we will solve some problems from your exercise. Okay. Thank you.